The Galilean moons are the four moons of Jupiter discovered by Galileo Galilei around January 1610. They are by far the largest of the moons of Jupiter and derive their names from the lovers of Zeus, Io, Europa, Ganymede, and Callisto. They are among the most massive objects in the solar system outside the Sun and the 8 planets, with radii larger than any of the dwarf planets. The 3 inner moons are Ganymede, Europa, and Io participate in a 1-4 orbital resonance. The 4 moons were discovered in either 1609 or 1610 when Galileo made improvements to his telescope, which enabled him to observe celestial bodies more distinctly than ever. Galileo's discovery showed the importance of the telescope as a tool for astronomers by proving that there were objects in space that cannot be seen by the naked eye. More importantly, the incontrovertible discovery of celestial bodies orbiting something other than Earth dealt a serious blow to the then-accepted Ptolemaic world system, or the geocentric theory in which everything orbits around Earth. Galileo initially named his discovery the cosmic Asidera, but the names that eventually prevailed were chosen by Simon Marius. Marius discovered the moons independently at the same time as Galileo, and gave them their present names, which were suggested by Johannes Kepler, in his Mundus Jovialis, published in 1614. History, discovery. As a result of improvements Galileo Galilei made to the telescope, with a magnifying capability of 20, he was able to see celestial bodies more distinctly than was ever possible before. This allowed Galilei to discover in either December 1609 or January 1610 what came to be known as the Galilean moons. On January 7, 1610, Galileo wrote a letter containing the first mention of Jupiter unregistered trademark S moons. At the time, he saw only 3 of them, and he believed them to be fixed stars near Jupiter. He continued to observe these celestial orbs from January 8 to March 2, 1610. In these observations, he discovered a 4th body, and also observed that the 4 were not fixed stars, but rather were orbiting Jupiter. Galileo unregistered trademark S discovery proved the importance of the telescope as a tool for astronomers by showing that there were objects in space to be discovered that until then had remained unseen by the naked eye. More importantly, the discovery of celestial bodies orbiting something other than the Earth dealt a blow to the then accepted Ptolemaic world system, which held that the Earth was at the center of the universe and all other celestial bodies revolved around it. Galileo's Sidereus Nuncius, which announced celestial observations through his telescope, does not explicitly mention Copernican heliocentrism, a theory that placed the Sun at the center of the universe. Nevertheless, Galileo accepted the Copernican theory. As a result of these discoveries, Galileo was able to develop a method of determining longitude based on the timing of the orbits of the Galilean moons. A Chinese historian of astronomy, Zai Zizong, has claimed that a small reddish star observed near Jupiter in 362 BC by Chinese astronomer Ganda may have been Ganymede, predating Galileo's discovery by around 2 millennia. Dedication to the Medicis. In 1605, Galileo had been employed as a mathematics tutor for Cosimo de' Medici. In 1609, Cosimo became Grand Duke Cosimo II of Tuscany. Galileo, seeking patronage from his now wealthy former student and his powerful family, used the discovery of Jupiter unregistered trademark S moons to gain it. On February 13, 1610, Galileo wrote to the Grand Duke unregistered trademark S secretary. God graced me with being able, through such a singular sign, to reveal to my Lord my devotion and the desire I have that his glorious name live as equal among the stars, and since it is up to me, the first discoverer, to name these new planets, I wish, in imitation of the great sages who placed the most excellent heroes of that age among the stars, to inscribe these with the name of the most serene Grand Duke. Galileo asked whether he should name the moons the Cosmian stars, after Cosimo alone, or the Medician stars, which would honor all 4 brothers in the Medici clan. The secretary replied that the latter name would be best. On March 12, 1610, Galileo wrote his dedicatory letter to the Duke of Tuscany, and the next day sent a copy to the Grand Duke, hoping to obtain the Grand Duke's support as quickly as possible. On March 19, he sent the telescope he had used to first view Jupiter's moons to the Grand Duke, along with an official copy of Sidereus Nuncius that, following the secretary's advice, named the 4 moons the Medicean stars. In his dedicatory introduction, Galileo wrote, "Scarcely have the immortal graces of your soul begun to shine forth on earth than bright stars offer themselves in the heavens which, like tongues, will speak of and celebrate your most excellent virtues for all time. Behold, therefore, 4 stars reserved for your illustrious name, which make their journeys and orbits with a marvelous speed around the star of Jupiter, like children of the same family. Indeed, it appears the maker of the stars himself, by clear arguments, admonished me to call these new planets by the illustrious name of your Highness before all others." Name. Galileo initially called his discovery the Cosmica Sidera, in honor of Cosimo II de' Medici. At Cosimo's suggestion, Galileo changed the name to Medica Sidera, honoring all 4 Medici brothers. The discovery was announced in the Sidereus Nuncius, published in Venice in March 1610, less than 2 months after the first observations. Other names put forward include, I Princiferus, 2. Victriferus, 3. Cosmiferus and 4. Finiferus, by Giovanni Battista Hodiana, a disciple of Galileo and author of the first Ephemerides. Circulators Jovis, or Jovis Comites, by Johannes Hevelius. Guards, or satellites, by Jacques Ozanam. The names that eventually prevailed were chosen by Simon Marius, who discovered the moons independently at the same time as Galileo. He named them at the suggestion of Johannes Kepler after lovers of the god Zeus, Io, Europa, Ganymede and Callisto, in his Mundus Jovialis, published in 1614. Galileo steadfastly refused to use Marius names and invented as a result the numbering scheme that is still used nowadays, in parallel with proper moon names. The numbers run from Jupiter outward, thus I, 3 and 4 for Io, Europa, Ganymede, and Callisto respectively. Galileo used this system in his notebooks but never actually published it. The numbered names were used until mid-20th century when other inner moons were discovered, and Marius names became widely used. Members, simulations suggest there may have been several generations of Galilean satellites in Jupiter's early history. Each generation of moons to have formed would have spiraled into Jupiter and been destroyed, due to drag from Jupiter's proto-lunar disk, with new moons forming from the remaining debris. By the time the present generation formed, the debris had thinned out to the point that it no longer greatly interfered with the moon's orbits. Io is anhydrous and likely has an interior of rock and metal. Europa is thought to contain 8% ice and water by mass with the remainder rock. These moons are, in increasing order of distance from Jupiter, Io. Io is the innermost of the 4 Galilean moons of Jupiter and, with a diameter of 3,642 kilometers, the 4th largest moon in the Solar System. It was named after Io, a priestess of Hera who became one of the lovers of Zeus. Nevertheless, it was simply referred to as a Euro-OE Jupiter I, a Euro or a Euro-OE, the first satellite of Jupiter, a Euro until the mid-20th century. With over 400 active volcanoes, Io is the most geologically active object in the Solar System. Its surface is dotted with more than 100 mountains, some of which are taller than Earth's Mount Everest. Unlike most satellites in the outer Solar System, Io is primarily composed of silicate rock surrounding a molten iron or iron sulfide core. Although not proven, recent data from the Galileo orbiter indicate that Io might have its own magnetic field. Io has an extremely thin atmosphere made up mostly of sulfur dioxide. If a surface data or collection vessel were to land on Io in the future, it would have to be extremely tough to survive the radiation and magnetic fields that originate from Jupiter. Europa. Europa, the second of the 4 Galilean moons, is the second closest to Jupiter and the smallest at 3,121.6 kilometers in diameter, which is slightly smaller than the Moon. The name, Europa, was after a mythical Phoenician noblewoman, Europa, who was courted by Zeus and became the Queen of Crete, but did not become widely used until the mid-20th century. It is one of the smoothest objects in the Solar System, with a layer of water surrounding the mantle of the planet, thought to be 100 kilometers thick. The smooth surface includes a layer of ice, while the bottom of the ice is theorized to be liquid water. The apparent youth and smoothness of the surface have led to the hypothesis that a water ocean exists beneath it, which could conceivably serve as an abode for extraterrestrial life. Heat energy from tidal flexing ensures that the ocean remains liquid and drives geological activity. Life may exist in Europa's under-ice ocean, perhaps subsisting in an environment similar to Earth's deep ocean hydrothermal vents or the Antarctic Lake Vostok. Life in such an ocean could possibly be similar to microbial life on Earth in the deep ocean. So far, there is no evidence that life exists on Europa, but the likely presence of liquid water has spurred calls to send a probe there. The prominent markings that crisscross the Moon seem to be mainly albedo features, which emphasize low topography. There are few craters on Europa because its surface is tectonically active and young. Some theories suggest that Jupiter's unregistered trademark S-gravity is causing these markings, as one side of Europa is constantly facing Jupiter. Also, volcanic water eruptions splitting the surface of Europa, and even geysers have been considered as a cause. The color of the markings, reddish-brown, is theorized to be caused by sulfur, but scientists cannot confirm that, because no data collection devices have been sent to Europa. Europa is primarily made of silicate rock and likely has an iron core. It has a tenuous atmosphere composed primarily of oxygen. Ganymede. Ganymede, the third Galilean moon, is named after the mythological Ganymede, cupbearer of the Greek gods and Zeus's beloved. Ganymede is the largest natural satellite in the Solar System at 5,262.4 kilometers in diameter, which makes it larger than the planet Mercury, although only at about half of its mass since Ganymede is an icy world. It is the only satellite in the Solar System known to possess a magnetosphere, likely created through convection within a liquid iron core. Ganymede is composed primarily of silicate rock and water ice, and a saltwater ocean is believed to exist nearly 200 km below Ganymede's surface, sandwiched between layers of ice. The metallic core of Ganymede suggests a greater heat at some time in its past than had previously been proposed. The surface is a mix of two types of terrain: highly cratered dark regions and younger, but still ancient, regions with a large array of grooves and ridges. Ganymede has a high number of craters, but many are gone or barely visible due to its icy crust forming over them. The satellite has a thin oxygen atmosphere that includes O2, and possibly O3, and some atomic hydrogen. Callisto. Callisto is the fourth and last Galilean moon, and is the second largest of the four, and at 4,820.6 kilometers in diameter, it is the third largest moon in the Solar System. Callisto was a daughter of the Arcadian king Lycaon and a hunting companion of the goddess Artemis. It does not form part of the orbital resonance that affects three inner Galilean satellites and thus does not experience appreciable tidal heating. Callisto is composed of approximately equal amounts of rock and ices, which makes it the least dense of the Galilean moons. It is one of the most heavily cratered satellites in the Solar System, and one major feature is a basin around 3,000 km wide called Valhalla. Callisto is surrounded by an extremely thin atmosphere composed of carbon dioxide and probably molecular oxygen. Investigation revealed that Callisto may possibly have a subsurface ocean of liquid water at depths greater than 100 kilometers. The likely presence of an ocean within Callisto indicates that it can or could harbor life. However, this is less likely than on nearby Europa. Callisto has long been considered the most suitable place for a human base for future exploration of the Jupiter system since it is furthest from the intense radiation of Jupiter. Comparative structure. Fluctuations in the orbits of the moons indicate that their mean density decreases with distance from Jupiter. Callisto, the outermost and least dense of the four, has a density intermediate between ice and rock, whereas Io, the innermost and densest moon, has a density intermediate between rock and iron. Callisto has an ancient, heavily cratered and unaltered ice surface, and the way it rotates indicates that its density is equally distributed, suggesting that it has no rocky or metallic core but consists of a homogeneous mix of rock and ice. This may well have been the original structure of all the moons. The rotation of the three inner moons, in contrast, indicates differentiation of their interiors with denser matter at the core and lighter matter above. They also reveal significant alteration of the surface. Ganymede reveals past tectonic movement of the ice surface which required partial melting of subsurface layers. Europa reveals more dynamic and recent movement of this nature, suggesting a thinner ice crust. Finally, Io, the innermost moon, has a sulfur surface, active volcanism and no sign of ice. All this evidence suggests that the nearer a moon is to Jupiter the hotter its interior. The current model is that the moons experience tidal heating as a result of the gravitational field of Jupiter in inverse proportion to the square of their distance from the giant planet. In orbit Callisto this will have melted the interior ice, allowing rock and iron to sink to the interior and water to cover the surface. In Ganymede a thick and solid ice crust then formed. In warmer Europa a thinner more easily broken crust formed. In Io the heating is so extreme that all the rock has melted and water has long ago boiled out into space. Size. Latest flyby. Visibility. All four Galilean moons are bright enough that they could, if they were farther away from Jupiter, be sighted from Earth without a telescope. They have apparent magnitudes between 4.6 and 5.6 when Jupiter is in opposition with the Sun, and are about 1 unit of magnitude dimmer when Jupiter is in conjunction. The main difficulty in observing the moons from Earth is their proximity to Jupiter since they are obscured by its brightness. The maximum angular separations of the moons are between 2 and 10 minutes of arc from Jupiter, close to the limit of human visual acuity. Ganymede and Callisto, at their maximum separation, are the likeliest targets for potential naked eye observation. The easiest way to observe them is to cover Jupiter with an object, for example, a tree limb or a utility pole that is perpendicular to the plane of the moon's orbits. See also, Moons of Jupiter, Jupiter's moons in fiction, references. External links, animation of Galileo's observation, March 1613. Sky and telescope utility for identifying Galilean moons.